everyone, welcome back to another JavaScript daily coding challenge. The challenge for today's video is you are given a matrix of numbers. Matrix is nothing but an array of arrays representing potential landing spots for your rover. Find the safest landing spot based on the following rules. Each spot in the matrix will contain a number from 0 to 9 inclusive. Any 0 represents a potential landing spot. Any number other than 0 is too dangerous to land. The higher the number, the more dangerous. The safest spot is defined as the 0 cell whose surrounding cells have the lowest total danger. So the surrounding cells we should take up to 4 neighbors. Ignore diagonals. Ignore out of bounds neighbors. Return the indices of the safest landing spot. There will always be one safest spot. Okay. For example, for this matrix, the output should be 0, 1 because we have a 0 at 0, 1 index as well as 1, 1 indices. But the surrounding neighbors sum, if you take the first 0's surrounding neighbors sum, it's only 1 because we don't have any right up but down is 0. So sum is 1. For the second cell having 0, the sum is 2 because here we have a left 2 plus no up is 0, no right and then no down. So 2 plus 0, 2. 1 is less than 2. So the output should be 0, 1 indices which is containing 0. Okay, let me explain with another example. Let me take this example and then explain again and then we go for solution for this challenge. So if you see here we have a total 4 arrays inside an array. So if we put all into matrix form, we get this 9608, that is first array, 7110, that is second array, 3039, that is third array, and then 8609, fourth row. So now here if you see 0, the first 0 is at 0, 2 and the sum of 4 neighbors. If you see for this cell we have a left, that is 6, and then we have a right 8. We don't have up, okay, so but we have a down, that is 1. So 6 plus 8 plus 1 equal to 15. Here the sum is 15, danger sum is 15. Now the second 0 is at 1, 3, okay, and the sum surrounding neighbors sum is 1 plus 8 plus 9. We don't have any right, okay, the sum is 18, danger sum is 18. Again the third 0 is at 2, 1, okay, and the sum of surrounding neighbors, okay, for this cell the neighbors are 1, 3, 6, 3, okay. If you sum all these values we get 13. So the last 0 is at 3, 2 and the sum of surrounding neighbors is 6, 3, 9. So total 18. So out of this 15, 13, 18, 18, the lowest value is 13. So the output should be 2, 1. Okay. So like this, we should design solution for our problem which should work, okay, which should work, and then all of our test cases should pass as expected. Okay, let's get into the solution for this challenge. For that, let me initialize a variable to store the coordinates of the safest spot. Okay, for that, safest spot equal to null. Initialize with null. Now let's take another variable and then initialize to keep track of minimum danger level found so far. Okay, for that let's take min danger equal to infinity. Okay, so we should initially assign the large value, and then as and when we get the minimum danger less than to infinity, we should keep on swap. Okay, so that's the reason I took infinity. Now let's loop through each row of the matrix. For that, let I equal to 0, I less than matrix dot length. Okay, I plus plus, and then again we should loop through each column in the current row. Okay, the first for loop is to loop through rows, and the second for loop is to loop through columns. For that, let j equal to 0, j less than the length of that row. Okay, that is matrix of the length of current row, matrix of I dot length, j plus plus. Here what we have to check is, check if the current cell is a potential landing spot, that is containing 0 or not. For that, the condition is if matrix of I j equals to 0. If the current cell value is 0, then let danger sum. This is to calculate the total danger around the current cell. Okay, let danger sum equal to 0, and then let's calculate total danger. For that, first we should take up value. For that, the condition is if I greater than 0. Why we are using this condition is, we should check if the cell is not in the first row. If the cell is in the first row, we don't have any up. Okay, if you see here, if the cell is in the first row, there is no up. Okay, for that reason we are using condition, that is check whether the row is greater than, that is row is not equal to first row. Okay, then if that is the case, let's find the danger sum. Okay, and then use matrix of I minus 1 and then j. Why? Because if you want to get the up value, we should decrease the I index. Why? Because if you see here, the up for this 0 cell is, let's say this is 2 comma 1. So to get the up value, we should decrement I index, that is 2 minus 1, and then that becomes 1. So that is the reason I am using here matrix I minus 1 and then j. So this is to get the up. Now to get the down. Okay, further the condition is the current row should not be the last row. then only we will have downsell. For that, I less than matrix dot length minus 1. Okay, the I value should be less than matrix dot length minus 1. Then only we will have downsell for the current cell. Okay, if that is true, then simply add sum to the add value to the danger sum. Here the value should be I plus 1 and then j. Why? Because if you want to find the down cell, we should increment the row. Okay, that is the reason I am incrementing the current row. Now let's find out left. Okay, left value. For that, if j greater than 0, then only we will have a left cell for current cell. Okay, in that case, let's add the value to left value to danger sum. Here j minus 1, because we should decrement the column value to get the left. So similarly, to get the right value, the condition is j should be less than matrix of I dot length minus 1. Okay, then only we will have right cell for current cell. In that case, we should increment the j value. So with this, we get the danger sum. Okay, now what we have to do is we should check, okay, if danger sum is less than minimum danger. Okay, then why? Because the perfect landing spot is the cell which is containing 0 and then the total value of surrounding neighbor should be less. Okay, lowest total. So that is the reason I am using this condition here. If danger sum is less than minimum danger, then minimum danger will become the danger sum. Okay, on the spot, safest spot will be I comma j. Okay, I comma j. Okay, so once we are done with this for loop, we get both minimum danger as well as safest spot. So but we should return only the safest spot. So simply return the safest spot here. Okay, return. So now let's see whether our solution is working or not by running the test cases. Click on here. See, all of our test cases passed. Okay, that's it about the solution for this challenge. If you like the video, please do like and share and subscribe for more technical videos to improve your coding skills. Thank you for watching.